Bismillahirrahmanirrahim. Assalamu alaikum, student. Student, today we will solve the problems of this chapter number 18. These are the problems about chapter number 18. And chapter number 18 was about ray optics. So we have already studied this chapter and finished this chapter. And you remember that we have studied about the refractive index, n is equal to c over v. And then we have studied Snell's law, n1 sine of theta 1 is equal to n2 sine of theta 2. And also there are two laws of reflection and two laws of refraction. And then we have studied about the thin lens formula, 1 over f is equal to 1 over s plus 1 over s dash. And then we have studied about the magnification, m is equal to minus s dash over s is equal to h dash over h. So s dash is the distance of the image from the optical center, and this is the distance from the object from the optical center, and this is the height of the image, and this is the height of the object. So normally we are using these formulas to solve these problems. So uh, easy problems you should solve for your final exam. Okay. So let's start this problem. A coin is 12 centimeter in front of a converging lens with a focal length of 4.0 centimeter. Where is the image? So where is the image? So we have to find what? S dash. Okay. So in this problem, we have coins 12 centimeter in front of a converging lens. So you know that this is our converging lens, and an coin and any object is placed in front of this one is S. So it means this value is actually S. Here in these problems, you should extract the data. First, front of a converging lens with a focal length of magnitude, this one. So the focal length is 4 centimeter. So it means this is the F value. Where is the image? So it means we have to find the S dash. So just apply the formula and solve it. It's very simple and easy. So 1 over F is equal to 1 over S plus 1 over S dash. So 1 over F is 1 over 4 is equal to 1 over 12 plus 1 over S dash. So 1 over 4 minus 1 over 12 is equal to 1 over S dash. So we can write it 1 over S dash is equal to 1 over 4 minus 1 over 12. So in this way, you can find the value. This is 12 and this is 3 minus 1 is equal to 2 over 12. And this is equal to 1 by 6. So 1 over S dash is 1 by 6. And S dash will be 6 centimeter. So this is the answer is the 6 centimeter. Here you can see there are two answers. One is 6 centimeter in front of the lens. Front of lens mean here. And 6 centimeter behind the lens. Behind the lens mean it is here. So surely it is a converging lens and the image will be here. Okay. So you know that the image is normally like this one, where it is cutting. This is the image. So it is behind. So that's why the answer is this one. I think you understand this one. Okay. Okay. After this, now we have another problem, and this is also about the same formulas. An object is placed 10 centimeter from a convex lens. Same, this is the convex lens and this is the object is placed 10 centimeter. So it means this value is S. With a focal length of magnitude, F is equal to 20 centimeter. What is the magnification? So we have to find the M value. So M formula is what? M formula is equal to S dash over S. Normally we write here minus sign, but here I'm not writing minus, I'm writing here positive, and H dash over H. Okay. Now we want to find what is the magnification. So to find the magnification, first what we will do, we have this value. If we, because the height of the image and the height of the object, we don't know. So only we know this S value, and S value is what? 10, and S dash value we don't know. So we will find this S dash value. So to find S dash value, we have to apply 1 over F is equal to 1 over S plus 1 over S dash. So 1 over F is 1 over 20, and this is equal to 1 over 10 plus 1 over S dash. So 1 over 20 minus 1 over 10 is equal to 1 over S dash. Okay. So this is equal to 20, and 1 minus 2 is equal to 1 over S dash, and this is minus 1 over 20 is equal to 1 over S dash. So S dash is equal to minus 20 over 1 or minus 20. So here the answer will be minus 20 over 10, and this is equal to minus 2. So it is not a minus 2, it will be plus 2. Why? Because it is already minus here. Here is minus. So that minus and this minus will become plus. So this is plus 2. So answer is this one. I think you understand. Okay. After this, now see this problem. So in this problem, a slide projector needs to create a 98 centimeter high image. So 98 centimeter high image mean what? It is image. So it means it is H dash of a 2 centimeter tall slides. So surely this is your slide, and this is H. This is H. Okay. The screen is 300 centimeter from the slide. Slide mean this one. Okay. So surely the image will be on the screen. So if we have a screen here, and here is the lens, and here is the object, or this 2 centimeter tall slide. So its distance is 2 centimeter from here. Sorry, not a distance is here. Its height is 2 centimeters. So it means H dash is equal to 98 centimeter, and H is equal to 2 centimeter. The screen is, so screen is this distance. If this distance is S, this distance is S dash. It means the total distance S plus S dash. The screen is 300 centimeters from the slide. So this is your slide. So it means the total distance is given S plus S dash is 300 centimeters. This is given. Now what we will do? We want to find what focal length does the lens need. So it means we have to find the focal length. So to find the focal length, we know the formula 1 over F is equal to 1 over S plus 1 over S dash. Okay. But to apply this formula, but first see the magnification formula is what? Magnification formula is equal to S dash over S is equal to H dash over H. Okay. And M is equal to H dash. H dash is what? 98 over 2. And this is equal to 49, and 49 is equal to S dash over S. So here S dash will be 49 into S. Now we will put this value here, 1 over S plus 1 over 49S. And 1 over F value is, we want to find 1 over S value. Okay, 1 over F value. So what we will do? So here you can see that S dash value is 49S. First, we will put this S dash value here. S plus S dash is 49. S is equal to 300. And this is equal to 50. S is equal to 300. And S is equal to If we cancel this 300, then it is 6 centimeter. So it means S is 6 centimeter. So what we will do, and S, if S is 6 centimeter, then what will be the S dash? It is 49 multiplied by 6. So you can solve this one. 294 centimeter. Okay. Now we can put the value 1 over F is equal to 1 over S. S is 6 plus 1 over 249 centimeter. Now from here you can find the value of F. So if you solve in the calculator and find the value of F, it is 5.88 centimeter, like this one. And S value is what? Here he asks how far. How far means the distance. You place the lens from the slide. So the distance of the lens mean S value. So S value is 6 centimeter. This one, this is the B part answer, and this is the A part answer. So in this way, you can solve this problem. Okay, understand. Okay, after this, now we have an object is 0.5 meter from a diverging lens. Diverging lens mean it is like this one. This is the diverging lens with a focal length of minus 20 centimeter. So here the value of an object is 0.5 meter. So first what you will do, you will, this is the S value and you will convert it into centimeter. So centimeter is 50 centimeter because this is centimeter, and answer is all centimeter. So that's why we have to convert it into centimeter. If the all answers are in meter, then we convert this one to meter. Okay. After this, we know the value of the focal length because this is diverging lens, and in diverging lens, the focal length is f is equal to minus 20 because it is negative value. Now the question is, how far from the lens is the image, mean S dash, and on which side of the lens it is it? So you should remember that in case of diverging lens, the image is always on the same side where the object is placed. Suppose object is here, the line, the ray of light is going in this direction, and then uh, if you draw the line and that line passes through the optical center, it is straight like this one. And when you reverse it, it cut here, and here is the image. So the image should be on the same side. This is, you should know this one. Okay, we will find the S dash value. So to find the S dash value, apply the formula same. 1 over F is equal to 1 over S plus 1 over S dash. So here F value is given 1 over minus 1 over 20 is equal to 1 over 50 and plus 1 over S dash. Now you can solve this one. This is easy. 1 over 20 minus 1 over 50 is equal to 1 over S dash. So if you solve this one, this is minus 7 over 100 and this is equal to 1 over S dash. So S dash will be equal to 100 over 7 with negative sign, but distances are positive, so you should write here 14.28 centimeter. So it is 14 centimeter around, but what is the answer? On the same side, on the opposite side, but on the same side here. So it means the answer is this one. Okay, after this, a diamond is underwater. A light ray enters on one face of the diamond at an angle of 25 degree. With respect to the horizontal, where the refractive index of the diamond is 2.41 and the refractive index of water is 1.3. What is the angle at which the ray travels inside the diamond? Inside the diamond mean this is water and this is diamond. Okay. And this is the interface. And if the ray is coming, actually the ray should go straight, but due to different media, water and diamond, it will bend. So here they have written the value of this one. with respect to the horizontal, this 25 is given with respect to horizontal. So this angle you have to find, and this is 65 degree. And this angle we have to find. This is for diamond and this is for water. No, here the refractive index of water and here the refractive index of the diamond. So we apply the Snell's law. NW sine of theta W is equal to ND into sine of theta D. No, we need theta D. So what we will do, we write ND into sine of theta D. Theta D is equal to NW sine of theta W. So sine of theta D is equal to NW. NW is what? The refractive index of the water, and this is 1.33. It is given into sine of theta W is water is 65 degree divided by ND. ND is what? The refractive index of diamond. This is 2.41. Now you can solve this one, okay? And when you solve this one, you will get 0.500 around this answer. You can see and check. And theta D is equal to sine of inverse 0.500. So theta D is equal to 30 degree. So in this way, you can solve this problem, the important problem. And like this type of problem normally come in the exam, okay? So here, any media can be given. Suppose the light is going from here and then here or here or here. Is the same thing. So you have to apply the Snell's law. Okay. Okay. After this, now I want to solve this problem. This is I think easy and simple. You need to use a 24 centimeter focal length lens. So here f value is given and this is your f 24 centimeter. To produce an inverted image is always real. Twice the height of the object, okay? So twice the height of the object mean that if the height of the object is h, then height of the image will be h dash. So the distance of the object from the lens will be what? So we have to find the s value, okay? So what we will do, first we write the data. F is equal to 24 centimeter. This is the value. And here h is the height of object. And then h dash is equal to 2h. This is given twice. Twice mean 2 times. So we have to find the s value. So to find the s value, we will take the formula. We will take this formula. Magnification is equal to s dash over s is equal to h dash over h. You know this one. So s dash over s is equal to h dash is what? 2h over h. Okay. So here h is cancelled and s dash over s is equal to 2. So s dash is equal to 2s. So here you can put the value in the formula. F is equal to 1 over F is equal to 1 over S plus 1 over S dash. So 1 over F is how much? 1 over 24 and 1 over S is we have to find 1 over S. 1 over S plus 1 over S dash, 2S, like this one. So you can solve this one. Here this is 2S, SS cancel 2 plus 1. And this is 1 over 24. So this is equal to 3 over 2S. So 1 over 24 is equal to 3 over 2S. So this implies 2S is equal to 24 into 3 divided by 1. So S is equal to, this is 72 over 2 and this is equal to 36 centimeter. So this is the answer. So these are the problems and I solved the easy problem. Why I solved easy problem? Because in the final exam, inshallah, you will see the problems will be easy. So that's why I solved this easy problem. Okay. I think you understand these problems. Okay, thank you.